welcome to True Projects. In this video, we are going to explain about a project titled Cat Dog Classification using CNN model. With ever increasing popularity of the deep learning and its potential to transform the image recognition task, we embark on an exciting journey to develop an accurate and efficient system for distinguishing between our two favorite four-legged companions of cats and dogs. Leveraging the power of MobileNet V2 and the custom-designed CNN architecture, we aim to create a robust and lightweight model that not only provides the state-of-art classification accuracy, but is also optimized for deployment on the mobile devices. Through the extensive training and the diverse data set, we strive to enhance the model ability to discern the subtle features and deliver the real-world particularity. And the objective of our project is to develop a highly accurate and efficient system for distinguishing between the cat and dog images. Leveraging the power of MobileNet V2 and the custom-designed CNN architecture, we aim to achieve a state-of-art classification model that only surpasses the existing methods but also remains the lightweight and suitable for the deployment on these platforms. Through extensive training on a diverse dataset of cat and dog images, our goal is to enable the model to learn intricate features and achieve the superior performance in the real-world scenarios. And these are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7 or Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. In this step, the necessary Python libraries are imported. Commonly used libraries like TensorFlow, Keras, NumPy, and Matplotlib are essential for building and training the CNN model, processing the image, handling the array, and visualizing the data. And the second step is importing the dataset. The project requires a labeled dataset of cat and dog images. These images are imported from a local directory or the dataset is divided into the two folders, one of cat images and other of dog images. This step ensures the availability of the data for training and testing the model. And the third one is image scaling and processing. To feed images into the CNN model, they need to be processed and standardized. This involves resizing all the images to specific dimension and converting them into the numerical arrays using the image processing libraries like OpenCV. The pixel values are often normalized to range of 0 to 1. And the next step is splitting into the training and the testing. The dataset is divided into the training and the testing subset. The training set usually comprises of data of 80% or 70%, and that is used to train the CNN model, while the testing set will be remind user to evaluate the model's performance. And the next step is building the model. Here and this we used the two models. The first one is MobileNet V2. MobileNet V2 with its depth-wise separable convolutions and the linear bottleneck reduces the computational complexity without compromising of performance. We employ the transfer learning by using the pre-trained MobileNet V2 weights as of the feature extractor, significantly speeding up the training process. And the next one is CNN. The custom CNN model is tailored for the cat-dog classification, comprising a series of convolutional, activation, pooling, and fully connected layers. This architecture enables the model to learn the hierarchical features specific to cats and dogs, enhancing its ability to differentiate between the two classes. And the next one is training the model. The training process involves feeding the pre-processed images through the architectures. During training, the model's parameters are adjusted through the backpropagation and the gradient descent optimization. The objective is to minimize the classification error and enhance the model's ability to correctly classify the cat and dog images. And the next one is user gives the input. To make the model accessible to the users, a user-friendly interface is created using a Flash web application. Users can interact with the model by uploading their own cat or dog images through the application interface. And the next step is the given input is pre-processed per prediction. Once a user uploads an image, it undergoes the processing step as of the training data. This involves image resizing, conversion to the numerical array, and normalization. The pre-processed image is then ready to fed into the trained model for the prediction. And the next step is trained model is used for the prediction. The pre-processed image is passed through the MobileNet V2 and the custom CNN model. The MobileNet feature extractor captures the essential feature, while the CNN model fine-tunes these features with the cat-dog classification. The model's final output represents the probability of the image being a cat or a dog. And the next step is final outcome is displayed. Here, the model prediction is displayed to the user through the Flash web application. The user can see whether the uploaded image is classified as a cat or a dog, along with the confidence score of the prediction. This user-friendly presentation enables the individuals to enjoy and experience the power of AI in identifying their beloved friends. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it, the static folder containing of the images and the models and the JavaScript file within it, and the template folder containing of the HTML documents within it as classify and home, and the upload folder containing of the images that will be used to perform the testing of the model. And the app is an py file which likely contains the information of the front-end logic related to it. It includes the code written in Python that handle the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML templates. And this is an IPYNB file which contains the combination of codes, graphs, and outputs at one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And for the execution, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to first write a command cd space and paste this code folder path. By this, it will change the current directory to the code folder's path, and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any logical issues or syntax errors, and then click on the enter button. After running this app.py file, the Flash framework will host the application locally at the default address. As of like this, we need to copy this local link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and clicking on the enter button. Here it will redirect it to this page containing of the some title and containing of upload an image and classify buttons. Here click on the upload image button, and here it will redirect it to this folder containing of various images within it. I am selecting one and then click on the open button, and then click on the classify button. Here it will be classified as this is a dog with a confidence level of 99%. And by clicking on the back to home button, it will redirect it to this home page, and here we can upload the another image by using the upload an image button. And I'm selecting one image and then click on the open button and then click on the classify button. Here it is classified as of cat with of confidence of 100%. In this way, we can classify the dog and cat by using the CNN model. And in conclusion, our project successfully achieved its goal of implementing a cat and dog classification system using the MobileNet V2 and the CNN architecture. The model demonstrated exceptional accuracy in distinguishing between the cat and dog images, while its lightweight nature ensured the efficient deployment on mobile devices. Through the rigorous training and the fine-tuning, we optimized the model for the real-world applications, benefiting the pet owners, animal shelters, and the veterinary clinics. Our system practicality and accuracy pave the way for the broader adoption in the pet care industry, streamlining the image recognition task and improving the overall pet welfare. As we look ahead, I remain committed to advanced AI application and making a positive impact on the society.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.